The go live button has been clicked. We should see people,
Awesome.
like the little eyeball up here should start populating shortly when we're actually live. So we'll give it just a second. There we go. I see 44. I think that means that we are actually live. Yes, we're on YouTube. Hello, GM. Welcome, everybody. How's it going? While we're just kind of waiting for everything to get started, I bet some of you know the drill already, but I love to hear where everybody's from when these things get started, because it just blows my mind every time to see how many countries are here on this video. So if you want to drop in the chat where you're from, what time of day it is there too. That's the other thing that blows me away. Here it's 9 o'clock in the morning. I'm in the United States. And so, yeah, I know people join from all over. U.S. Virgin Islands, see, Italy. What? This is crazy. Man, it sounds like you guys are in the places I want to go for vacation. So yeah, we have an exciting workshop today. We are going to be building a cross-chain NFT. I'll explain what that means and everything like that. We also have Antonio here from ZKsync, because we're going to be building with ZKsync today. So I don't know if you want to say a few words, Antonio, introduce yourself.
Yeah, definitely. So hello, everybody. Good morning, or it depends where you are. My name is Antonio, and I'm a developer relations engineer at Matter Labs, which is the team behind ZKsync and ZKsync Era, which is a layer 2 rollup. And yeah, today we're going to do a super cool demo using CCIP. And I'll show you also a little ZKsync specific feature that will, I will tease you a little bit with that. So apart from doing this cross-chain NFT, we're going to do something else with ZKsync and native account extraction. So yeah.
Yeah, so that's a little teaser. At the end of this, Antonio's got like a little extra spice to sprinkle on there for what you can do with this NFT once you get it transferred across. So we'll be building an NFT on Ethereum Sepolia. We'll also be deploying the same contracts on ZKsync Sepolia, and then we'll be using CCIP to transfer it across. And one thing to know about CCIP is it does take a little bit of time. There's a couple reasons for that. We'll talk about it a little bit more, but it needs to reach finality on the chain that it's transferring from, and then it actually will do things on the chain that it's transferring to. So with that in mind, I'm going to start kind of at the end of our project and just kick something off, show you all that, and then we'll build it all out and get there. But this way, by the time we get done building, we'll have this done. It's kind of like those, I already had one of these in the oven and it's already baked. So I'm going to share my screen real quick and just kind of show you, this is where we're going to be ending up with a contract that we will send a NFT across chains. So I'll run this command here to call this script, and this will actually transfer our NFT across. So we have this transaction. I'll go ahead and look at this in the CCIP Explorer too. And we'll be doing all this. I know you're probably like, what the heck is going on if you're just joining? This is just kind of a preview of where we're going. So I've started a CCIP transfer. It's going to take a minute. You can see here it's going to take 20 minutes. So instead of everybody waiting 20 minutes, we'll come back when we get done and we'll check this out and we'll see that it's done. So that's just kind of a tease. And I think from here, Antonio's going to talk a little bit more about what ZKsync is, why ZKsync, and then we'll start building our contracts out. So I'll drop myself off the screen. And Antonio, if you want to share your screen.
Yeah, I'll take over. So let me know when you guys can see this.
There you go. You should be good.
Okay, so I'm going to put this in slideshow mode. Okay, so I'm going to talk a little bit, like 10 minutes. We'll be fast, and then we'll move on to coding. So I'm going to give you in 10 minutes like a quick overview of what is ZKsync and the Elastic Network. So I'm sure a lot of people have heard about ZKsync before. We've released different versions of ZKsync, and nowadays it might be a little confusing to some people. So back in 4 years ago, ZKsync was what we know today as ZKsync Lite. It was a protocol to do just token swaps and sending ETH and tokens from one account to another. But that was it. That was ZKsync a few years ago. Then on 2023, we released ZKsync Era, which is version 2 of the protocol. ZKsync Era, it's a general purpose rollup. It's EVM compatible, so it's a full-blown blockchain where you can build any type of smart contracts, and yeah, with Solidity, just as on Ethereum. But it's a rollup with all the benefits that it brings, and I will expand on that a little bit. And the last version, what we call the Elastic Network, is because we know that the same way that internet doesn't run on a single server, we know that the new Internet of Value cannot run on a single blockchain. So what we did is we took all the pieces that we built to build ZKsync Era, and we open sourced that, and we built ZK Stack. It's a stack to create chains that can be deployed as rollups or as validiums. It's very, you can set it up as you want, so you can build a lot of networks. So these are like the 3 different versions of ZKsync. So it depends on the context. ZKsync can mean one thing or another. If you are an application developer, if you're just playing around with ZKsync, you want to deploy some contracts, just start building on ZKsync Era, which is what we are going to do today. So getting a little bit deeper into what is ZKsync Era, again, it's a general purpose layer 2 rollup that scales Ethereum, and it uses zero knowledge. That's like a mouthful. So in general, what we do is it increases the throughput of Ethereum. I'm sure you know that Ethereum can do like 16, 20 transactions per second. With a layer 2 or with a rollup, what we do is we execute hundreds of transactions per second. So a lot more throughput, and the fees are way cheaper. When you are paying $1, $3, maybe $10, sometimes and 20 on Ethereum, on L2s, you're paying cents. How is that possible? But it's because instead of waiting for all the consensus that is happening on the layer 1, etc., we move the execution of the transactions of the layer 1 onto the layer 2, and that way we can handle more transactions per second. We still use Ethereum to maintain the state of the layer 2, which means that the security guarantees that Ethereum provides apply to the layer 2s as well. And finally, we use zero knowledge tech, which is something quite new. I mean, ZKsync was the first ZK EVM, and it was released in 2023, ZKsync Era. And how it works is we execute all these transactions on the layer 2, and we generate a proof that the new state that happens after executing these transactions, like I transfer you to some ETH and you deploy some contracts, that generates a new state of the blockchain. So we generate a proof that after executing these transactions, we're getting this state, and we send the new state plus the proof to Ethereum, where the proof is verified, and if it's valid, we do a state transition. So the state of the layer 2 is kept on a smart contract on Ethereum, and it's where it's verified. That's why we maintain the same security guarantees. That's like a super fast version of how rollups work and how ZKsync Era works. Apart from that, on 2023, releasing a ZK EVM or a rollup that uses zero knowledge and that was EVM compatible was like super new, but we are in 2 years later, and there are multiple ZK EVMs, there are multiple layer 2 rollups that use zero knowledge, but there are still some things that makes ZKsync Era different. And the first one is that it's EVM compatible. So if you know how to build on Ethereum, you know how to build on ZKsync. You can use Solidity, Viper, and Viper. The only thing is that we have custom compilers. So instead of compiling your contracts with the Solidity compiler, you will use ZKsync, or with the Viper compiler, you will use ZK Viper. But as we will see later on, We have plugins for the most popular libraries and frameworks, so nothing to worry about. Again, performance. Right now, ZKsync is able to handle more than 200 transactions per second while maintaining super low fees. And how do we do that? Because ZKsync uses this thing called state diffs. And the way it works is if during a batch of transactions, you are updating the same storage slots. When I say storage slot, it's like if I'm updating the price, a price of an oracle. Like if I'm Chainlink and I'm updating the price of USDC, I can update the price like every second. So during like a minute, I will update the price 60 times. Instead of paying for these 60 transactions, as at the beginning of the batch of transaction, I had a price, and then at the end I have another, and all I have done is update the same information in the blockchain, I would only pay one update at the beginning of the batch, which makes, you're making a lot of savings for certain types of applications like oracles. This is huge because you're saving on fees a lot. And then the last one is native account abstraction. And I'm going to expand on this a little bit. Last year, everyone was talking about account abstraction. It's still really not there. On ZKsync, account abstraction is integrated at the protocol level. I will explain a little bit more about that. So account abstraction is this thing that is going to revolutionize UX and how we interact with Web3 applications. It's supposed to be great, but today the only thing that we have on mainnet, on Ethereum mainnet, is EIP 4337, which is this thing that enabled smart contract accounts. Apart from that, there are a lot of EIPs being discussed, but nothing really is available yet. We have just EIP 4337. And on ZKsync, we were building a protocol from scratch, and we knew we wanted to implement this at the protocol level, so we did things slightly different than EIP 4337. So yeah, we integrated it at a protocol level, and I'll show you a diagram with the differences between how we did it on EIP 4337, but overall, it's a simplified version of it. It's way easier for both users and for developers. We have a single mempool and a single transaction flow. So all transactions, no matter if they are initiated by an externally owned account like your MetaMask or from a smart contract account, they go through the same transaction flow. Smart accounts and paymasters are first-class citizens, and all accounts, even your MetaMask, behave like a smart contract account behind the hood, and all accounts support paymasters. I'll show you this in the little demo that I will do at the end. And the way this works is because we have our own version of the bundler and the entry point. We call them the operator, which is this process that handles or bundles transactions together and sends them to the bootloader, which is our version of the entry point contract, which is the one that executes the transactions. So how does this look like? This on top is how EIP 4337 works. At the top, you have a transaction flow for externally owned accounts like your MetaMask or your Sirion or your regular wallet. And then at the bottom, you have a totally separated transaction flow for smart accounts. It has a mempool for the externally owned accounts and a different mempool for the smart accounts, because they send this new object called user operations. So it's totally different. And it requires additional infrastructure because you need bundler nodes and things like that. On ZKsync, this is how it looks like. You have both types of accounts sending transactions, the same type of transactions to the same mempool. And then we have a single operator and this bootloader system contract. And we just execute the transactions from the mempool and we add them to the blockchain. So way simpler. There's no additional infrastructure that you need or things like that. Super quick. How does it look to build applications on ZKsync? As I mentioned before, you can use Remix, Hardhat, Foundry. We have plugins to use our compilers, so they are very easy to install. But you can use the same tools. Yeah, you compile your contracts with our compilers. Once your contracts are compiled, you want to build a front end, you can use VM, you can use WalkMe, you can use Ether. So again, same libraries, everything works out of the box. If you want to write another scripts because you need to interact with the with the blockchain for anything else, we have SDKs in Go, in Python, in Java, in Rust. I mean, I didn't include all of them, but no matter the language, we got you covered. And that's it. So it's same developer experience, but yeah, building on ZKsync. Obviously, when it comes to the ecosystem tools, we have everything that you will expect. Chainlink is there, of course. You have the graph, Gelato, Layer 0, Open Zeppelin contracts, anything you need, it's already there. Yeah, and finally, a few things that we have released recently. One is ZKsync SSO, which is a library to build smart contract accounts and implement them into applications. So, and the cool thing about this is that it implements passkeys and sessions. So basically, you will create an app that abstracts everything from the users, everything that is blockchain related. So there is no wallet needed, no need to sign transactions, not need to do anything else. And I can show you the demo at the end if we have time, because if not, you have the link there and you can try it, but I will show it at the end. Then this year, we're going to have full EVM equivalence through a new prover. So there will be no need for plugins, for tools, etc. And we'll have interop between ZK chains. A part of this elastic network vision is that all the chains will be able to interact with each other. If you have a contract in chain A, you will be able to call a contract that is deployed in chain B, and things like that. So we'll have this this year. SSO is available now to play, and we have a full roadmap here if you want to scan that QR code. Yeah, that's it. Yeah. Takeaways, yeah. RS rollup is built on Ethereum, same developer experience. You can use the same tools, account abstraction at the protocol level. Yeah, a few links here that we also have in the tutorial that we're going to do. So I will not steal more of your time.
Awesome. Thanks so much, Antonio. I saw in the chat, there's a couple questions. I think you got most of them that Rashid was asking. I feel like he was asking questions like right before you'd say the thing. But a couple that he was asking if when it's compiled, if it gets compiled to Yule first through the ZKsync compiler.
Yeah, it is.
Okay. And then he was asking about why like Foundry is supported via a plugin and not natively.
It's because Foundry is not built to handle alternative VMs, virtual machines, or compilers. So that's why we have a specific version. It's called Foundry ZKsync. You can install it along Foundry. So in your system, you can have Foundry to do your EVM projects, and then Foundry ZKsync when you need to deploy or build something for ZKsync. But we are talking with the Foundry team to try to open Foundry, not just only to support ZKsync, but also for other virtual machines and other blockchains. So it's just trying to make some changes so it's more extensible, let's say.
Okay, perfect. Yeah. And SA points out, yes, Remix also has a ZKsync plugin. I will say, like, it's not terribly difficult, but probably the most difficult part about ZKsync, in my opinion, is just making sure that you get that plugin so you're using the different compiler. So seeing that you're going to support like EVM stuff natively, I don't know. It's not difficult right now, but like that's like the hardest part, So it's great to see that that's coming.
Yeah, that's what everyone is really asking us to do, and that's the slightly friction that it is. No matter how much you work on it, any friction is always friction. So we're gonna try to remove it.
Yeah, perfect. That sounds awesome. Cool. So I think we'll transition to talking about the actual project that we're building now that we understand a little bit more about ZKsync. Do you want to stay on screen, or you want me to pull you off as we talk here and then bring you back on
I will
later?
stay and I will follow along for sure.
Okay, cool. I'll leave you on screen then. All right, so y'all been doing a good job of using the chat. If you have any questions as we're going through this, we're going to go quickly. Just kind of respect everybody's time. All of the steps are documented out so you can follow along at your own pace. Remember this video, you can like back me up. You can't 2x me yet, but if you're watching and you're not live, then you can 2x me. So everything that you need for this workshop will be here at this link. It's a Git book, has all the code that we're going to be going through, all the commands that you need, everything is there except for probably a private key, but those are yours, not mine. So you'll need to supply your own private key, and RPC URL probably too. So yeah, I will also say this is kind of geared towards a little bit more intermediate group. So it's not super beginner friendly. I'll try to cover everything. If you have questions, ask them. I will answer your questions for sure. But if you feel lost, don't fret. This is, where is it? It's over here. This is my X handle, so you can send me a DM on there if you have questions, and I'll get you sorted out too. Everybody good? I think we're good. Okay, I'm gonna share my screen and we'll get started. We are going to build a cross-chain NFT. We talked about this at the very beginning for like a split second. I didn't give you too much details other than we're going to be building this thing, and I ran some commands to kick off a CCIP transaction. You can see it's still running back here in the background. So this is why I didn't make us all just sit here and wait for that. So we're going to build a cross-chain NFT. Generally, when you think about NFTs, you think about them being on one chain. And if you want to have an NFT on another chain, you have to just deploy a whole new NFT project, right? What we're going to build is a set of contracts that will allow you to mint NFTs on Ethereum Sepolia. And then if you want to transfer them to ZKsync Sepolia, we can do that. And the same NFT that you minted, you can transfer across like in a one-to-one. It will get rid of your NFT on Ethereum and create a new NFT for you on ZKsync. So when NFTs can move between chains, that's what I'm calling a cross-chain NFT. At a very high level, what we're doing is burn and mint. That means that on the source chain, so Ethereum Sepolia in this case, we're going to burn or get rid of that NFT, destroy it. And on the destination chain, ZKsync Sepolia, we will then mint a new version of that NFT. There's other ways that you could do this. You could do a lock and mint. Lock means that you take hold of that NFT basically. It's no longer in the owner's wallet. It's locked up. They can't use it. And on the new chain, you mint it. This is nice because if you wanted to go backwards, you could burn on ZKsync and unlock on Sepolia, Ethereum Sepolia. And the final way that you could do this is with lock and unlock. So lock and unlock means you mint on both chains and you're just locking up and unlocking, or locking and unlocking on the other chain. Hopefully that's clear as mud. So yeah, so we'll be doing the burn and mint today. And again, if you have any questions, I saw somebody saying they were just joining, to go ahead and ask your questions in there. I'll take a moment and just kind of scan through the chat as we go and see if there are questions to answer, but I think we're good so far. And Saeed, shout out to you. You're doing an awesome job answering questions. Thank you so much. So how does CCIP play into this? So CCIP is the cross-chain interoperability protocol. CCIP basically lets you transfer tokens and data between blockchains using the Chainlink Oracle network. So if we have here just a basic illustration, so this is our source blockchain. In this example, this is going to be Ethereum Sepolia, and we have our destination chain, which is ZKsync Sepolia. So we're going to be building our NFT, and the NFT is going to have within it a function to send a message to CCIP, which will go to the router contract. Then it goes into the Oracle network. So CCIP behind the scenes will do a bunch of stuff, wait for finality, which is something that we're waiting on right now, or we were waiting on. Now you can see it's finalized. Hey, look at that, it worked. So we'll see what this did in a minute. But finality means that basically all the transactions on a blockchain are done. They can't be reverted back. So that's what CCIP waits for, is to ensure that the transactions are finalized before it then sends information to the new chain. Depending on your source chain, that can take a lot of time. I don't know, Antonio, I'm gonna put you on the spot real quick. With ZKsync, finality is really different on ZKsync than Ethereum. And I don't know if you can speak to that, because I know it can sometimes take a long time to reach finality.
Yeah. So on mainnet today, just because, zero knowledge is a technology that is so new, when we launched the protocol, we included a delay on the state transitions that we do. It was a 21-hour delay in case that there was a bug or something that we had enough time to make sure to react and try to fix what was going on. That was until this week when there was a governance proposal. I mean, ZKsync is now decentralized, so all the protocol changes happen through governance. There is a governance proposal to decrease that delay to 3 hours. It's still longer than on mainnet, but we will keep decreasing that as long as the protocol evolves and it's been more secure. So that will be more or less the finality. So we hold the state transition changes for a little bit, then we send them to Ethereum, and that's when, once it reaches Ethereum and the proof is verified, you can consider it final.
Yeah. So going from Ethereum to ZKsync, like we saw, it takes about 20 minutes, but going from ZKsync to Ethereum, because we have to wait for that finality, it can take a bit longer. And it's just kind of, I feel like everything in this space with blockchains, there's always trade-offs, right? Like ZKsync, transactions are verified really quick and the costs are very low, right? But then your security mechanism, which is really secure, but using Ethereum as how you're securing things, that makes the finality piece take a long time. I don't think, other than CCIP, I don't know who would really care about finality all that much in day-to-day stuff. But for this example, that's where we're going from Ethereum to ZKsync. So yeah, so we'll be implementing a burn and mint. We're going to talk a little bit about the code. In the next section, we'll get to actually putting this code into practice. So on the Ethereum Sepolia side, I mentioned that we're going to have a function that enables us to call CCIP. So that's what this is here. Just to kind of walk through this briefly. And if you have questions that are walking through this, feel free again to drop them in the chat. I think I'm going to be explaining all the steps behind the scenes of how to implement this as we go through it. But if I don't get to them all and you still have questions, let me know. But this cross-chain transfer from is going to be run on the Sepolia side. So what we're going to be passing in is the to and from address. That's going to be, in the case of this example, the wallet that we're sending from and to, the token ID of the NFT that we're sending, the destination chain selector, which is an identifier for the chain that we'll be sending it to. So ZKsync's destination chain selector. And then if we want to pay our fees in link tokens or in native tokens. So we create a message, an EVM to any message type here that has all that information in it, right? It has our receiver, which is going to be the address for the contract on ZKsync, what data we're passing. So that's our from, to, and token ID, how much we're sending. And then this is more for sending tokens across. So in this case, we're just sending data across. Any extra args, and we'll see that extra args includes things like gas limits and stuff like that, which we'll talk about here in just a moment. And then if we want to pay in link or native token. And we go through, and get the fees required to make sure that we have enough link or native tokens to cover that. We send the message to the router, and we do a little bit of error checking down here, and we emit an event. So I know I'm going through this really quick. Again, you have access to this. It explains everything. I don't want to just read to you all as we go through this. So on the ZKsync Sepolia side, right? So on Ethereum, we send a message to CCIP. That's what we see up here, right? So we have our router that we're sending it to. So it goes into CCIP. Once it goes through CCIP, everything in the transaction reaches finality. We get to the router on the ZKsync side, and then we'll be sending a message into our contract on ZKsync. With this function, CCIP receive. So again, I'll take in that message, and from here, we'll get the from and to address, the token ID out, we'll mint our token, and emit another message. Cool. I think we're good. I don't see any big questions in the chat, so I'll move on. So what NFT are we minting? We're going to mint an NFT that has a couple different characters here. We call these the Chainlink warriors. They've got all their data hosted on IPFS. So if you wanted to take a look at that, you could. And they're stored there. IPFS just lets it be a decentralized file storage, so we can store them there, and it's always going to be there. For this process as well, we're going to use a couple best practices. We're going to verify our source chain, our destination chain, and the sender and receiver addresses, right? So we're basically controlling things with permission, so we can enable and disable chains, and we can enable and disable who can actually send and receive messages from this contract. Just as a little bit of security in there. So we see here that we have, our enabled chains, enabled senders. We have our function to enable and disable chains. Pretty simple, not too much to that. And we also need to verify our router address, and then we have the gas limit. So I mentioned gas limit earlier. And gas limit is basically the amount of gas that CCIP is allowed to spend when it calls into your contract. So when we call into our contract on the ZKsync side of things in CCIP receive, the maximum amount of gas that we can spend on this, that's what the gas limit is. So doing things like minting are going to be more expensive, right? So it's just something to kind of keep in mind, that you want to keep that cost as low as possible if you can. Some questions here. Can we use CCT to mint them all? So CCT is actually a cross-chain token. These are not CCTs. These are NFTs that we're making work cross-chain. We actually soon have a couple of videos coming on CCTs, so stay tuned for those. In our docs at docs.chain.link, there's more information about that. And Rashid, you bring up a good point. The NFT data on IPFS, if it's pinned, it'll be there. If it's something that you care about, you can pin it, right? Like, that's the nice thing. You can make sure that it always stays there. So how do we set gas limit? We talked about what gas limit is. We set gas limit using that extra args feature, and it's going to be encoded. So this is basically how you would go about encoding those extra args. In this example, I've already done that work for you, so you're just going to be able to copy and paste the results of your extra args out. Cool. So let's move on to the actual exercise. If you want to follow along, again, I'm going to be going kind of fast, so feel free to pause this video, take a look at the documentation for this workshop as well. I will, again, post it in the chat just so everybody has it. We've got a couple things up here at the top, just to kind of keep them handy. We have our chain selectors for ZKsync and Ethereum. We've got our CCIP router addresses, and we've got the address of the Link token as well, because we'll be using Link to pay for this. If you need any funds, you can go to our faucet. We'll get to that in just a moment. I'm going to be using Hardhat and VS Code for this. And just fair warning, if you can't tell already, I'm a light mode fan, so I'm not a dark mode guy. So, if you need to turn down your screen brightness, if you haven't already, it's just a warning. It's not going to get better from here. So yeah, we need to make sure we have Node installed and npm. We're going to start by making a directory for this project, and we're going to call it ZK CCIP NFT. And I probably am going to have to delete that directory because I already did this once. Whoops. Well, we'll see what that does. There's no maker. It's fine. So we will make that directory. We'll cd into it. And then we'll run npx hardhat init. From here, we're going to create a TypeScript project. So we run npx hardhat init, choose TypeScript, and just go with all the defaults. And it'll take a minute. I'm sorry, Rashid. I'm sorry about the brightness. Just turn down your screen brightness. It'll be okay. Cool. So we've got our hard hat project installed. From here, we're going to do a couple other installs. So we'll just kind of go back and forth between the two. So we'll install the Chainlink contracts for CCIP. So pop this over here. Someone's asking, why not Foundry? I mean, you could use Foundry if you wanted. The steps will be slightly different. Oh, how can I get the, come on, window manager. The steps will be slightly different if you wanted to use Foundry, but basically the same stuff would apply. Okay, so we installed our CCIP contracts. We're gonna install the rest of the Chainlink contracts as well. Then once those are installed, we'll install the Open Zeppelin contracts. Open Zeppelin contracts will give us stuff like the access to the ERC 721 contracts for our NFT.
Yeah, someone was asking about Foundry, but yeah, as we mentioned before, Foundry ZKsync is available, and if people prefer to use Foundry, they can use it. The main difference is that when you compile, instead of doing forge build, you will do forge build --ZKsync. That will use our compiler behind the scene. That's the main difference. So all the other things are pretty much the same.
Cool. Yeah. I like them both, Rashid. I like them both. So we installed the Open Zeppelin contracts, and now we get to actually create our NFT contract. So I'm going to open up VS Code from this point, and we'll go from there. Oh, this looks like it opened up an old version, maybe. I don't know. We'll get rid of this stuff. Okay. So open up VS Code, and inside the contracts folder here, we'll create a new file and call it xnft.sol. And we'll do every dev's favorite thing, Control C, Control V. Unfortunately, I'm not on Stack Overflow, but hey, it's almost as good, right? So let's take a quick tour of this massive contract, all 239 lines of code. So we've got all our imports up here. So this is all the stuff that we installed just a moment ago, right? All our Open Zeppelin contracts, our Chainlink contracts, our Chainlink CCIP contracts. We have our contract called XNFT for cross-chain NFT. We can see here that we're using ERC 721 from Open Zeppelin. We've got our CCIP, any message EVM. We've got some reentrancy guards, and owner is creator from our contracts that we imported as well. We've got an enum for if we want to pay fees in native or link. We've got a bunch of errors in case things aren't set up correctly. You know, like if you weren't on Sepolia when you were minting, or you used an invalid router, maybe you don't have enough balance for fees. We've got our XNFT details struct. We've got our characters. So these are those IPFS files that we saw earlier. And then we go through and we can see, you know, our modifiers just for protecting, make sure only the router, only on Sepolia, only on enabled chains by enabled senders. We can see all of that there. In our constructor, you can see we set up the router and link token as well, those addresses. And we also have our chain selector set there. We have a basic mint function here, nothing too fancy. We have a function to enable chains, so it adds it to the enabled chains. We can remove them from the enabled chains. We have a cross-chain transfer that we looked at earlier, and our CCIP receive that we looked at earlier as well. We have a function to withdraw any link that we have because we're going to be funding this contract with link so that then it can make that call for us. And then we have our token URI. So this basically is what's going to be returned as the JSON value for the token when it's actually minted. So instead of storing all that on the blockchain, we're just generating it as a view function. It can save a little bit of gas when you're actually minting and changing things within an NFT. So if you ever want to make an NFT that's dynamic, I highly recommend you look at creating your own token URI like this so that you can just change a few variables instead of changing the entire JSON object for the NFT. Cool. Any questions? Is there an upgradable option? This contract's not set to be upgradable, no. You could make it that way though. Cool. And yeah, Antonio's answering questions like a champion. Cool. So once we've got this in here, pro tip, make sure you save. If you see a little dot like this in your VS Code, that means you haven't saved. So many times I do things and then I try to run a command and I haven't saved. And I'm like, what the heck is going on? Why isn't this working? It's because I didn't save the file. So once we've got this in here, we've got it saved. We can do a little bit of cleanup too. We talk about this later on, but let's go ahead and get rid of this lock business from the default. So we'll delete lock.sol from our contracts here and also from test. And I've got bad news for those of you that love tests. I didn't write any tests for this little workshop. I'm sorry. It's something you could do on your own though. You could write tests. So we've got those two deleted. So we've just got our contract in here. We'll go ahead and run npx hardhat compile just to get everything compiled and make sure everything works. The other thing that this gives us is it gives us the types for these contracts, which is great. So we'll make sure, hey, everything's working, right? We compiled everything. Everything's happy. We've got our types in here, which we'll need later, and we're good. So if you made it to this point, we've got our contract already developed. Wasn't that fast? And again, later, if you have questions, feel free to hit me up on X. It feels wrong to say X, on Twitter, and I can help you out if you have any questions about what's going on in this that are deeper. So from here, we've got our basic contract. It compiles. We're going to install the ZKsync plugin so that now we can do things with ZKsync. So we'll go ahead and copy this and paste it in. So install Antonio's amazing plugin, also known as the Hardhat ZKsync plugin.
Definitely not mine.
Once this gets installed, we'll be going into our Hardhat config, and in here, the way that you implement this is you just basically comment out the Hardhat toolbox import and replace it with the Hardhat ZKsync import. So we can do that now that it's installed. And remember, give that a save. So this kind of sets up our Hardhat config, but we'll be adding a bit more to it in just a second. I mentioned earlier, we're going to be deploying to actual test nets. So you're going to need some funds if you don't have them already. I don't know, I'm assuming at an intermediate level, you've probably interacted with some stuff before. So if you go to faucets.chain.link, if you need link tokens, if you need native tokens for Sepolia or for ZKsync Sepolia, you can get them there. There is a bit of a gatekeeping to this faucet where you need some actual funds on mainnet because people love testnet funds. I don't understand it. Like, they've become worth real money. It's the bane of my existence as a developer advocate here. Like, people using monopoly money as real money. But hey, that is what it is. If you can't get funds from this faucet and you're in the chat right now and you need them, just drop your wallet address in there. We'll send you some funds to make sure that you can do this with us for sure. So from here, we're going to do a couple things. So we're going to need to set up our .env file, right? That's going to be where you're going to store things like your private key. And also if you have a RPC URL from something like Alchemy, which you'll probably need to work with Sepolia, you can put that in there as well. We're going to install, Chainlink has a encrypted version of .env, which I think is great because I don't know about you, but like I've definitely know of people, not me, but other people have checked things into GitHub. I would never check things into GitHub I didn't mean to check into GitHub. I've never done something by accident. Maybe I have. But if you put your private key in plain text in your .env file and you forgot to add it to your .gitignore, like this line right here is not there, then your private key goes up on GitHub. Then that wallet is useless because all the funds in that wallet will be gone. So Chainlink has an encrypted env that you can install. So if you just run this npm install and we can actually set a password to encrypt that file, and then we can use that later on. So I'm going to do that now. So we'll run set password. I'll set something super amazing as a password. Yes, that's right. My password is all stars. And then we'll use npx env-enc set to set the values that we're going to be storing in our encrypted env file. So the way that this works is you'll use your private key. We'll start with that. And then I'm going to do this just off screen a little bit because I'm always terrified that it won't be commented out. But I'm going to put my private key in there. See, it's good. Okay. So, I put my private key in there. And then we also need a ZKsync RPC URL. So we'll put that in there. Your ZKsync RPC URL, I don't know, do you have that handy, Antonio? You have a public one, sure. Right? That works for everybody?
Yeah, it's 100% public. It's in our docs.
Yeah, I've got it right here.
Okay.
I'll put it in the chat. So that's for ZKsync. And then for Sepolia, I use Alchemy. If you go to Alchemy, you can get a free API key from them for your RPC URL. I don't know, Antonio, do you have anywhere that you like to go to get them?
I use Chainlist.
Okay, so you just use one of the RPCs on Chainlist?
Yeah, just make sure you're actually on Chainlist. It always freaks me out. If you search on Google, maybe the first result is not the one, and then you connect your wallet and you're not real.
Yeah, so you can go to Chainlist too, which is always good. I don't know. Sometimes it works for me to use Chainlist, sometimes it doesn't. So yeah, if you take a look at the encrypted ENV now, hey, look, there's my private key, everybody. Oh, it's not really my private key. So the fact that I just, shared my private key on stream, it'll be okay. So once we have those created, we have our encrypted ENV file. You can run this npx env-enc view. It will show you everything in plain text. So I will not be doing that, but you can do that. We'll remove those two files that we removed earlier, and then the hard hat config, we'll go ahead and add a few things in there. So in our hardhatconfig.ts, we'll go ahead and add in a bunch of stuff, right? So we've got our import of the ZKsync hard hat plugin here. We're importing in the Chainlink env-enc, so we can use that and setting it up. So when we run this, it basically populates everything so that now process.env.private key is actually going to be my private key. We're setting up our compiler information. We're setting up our networks here. So this is where we see our Sepolia network and our ZKsync Sepolia network in here. So this is how we're actually going to connect to them when we're actually deploying these contracts. And yeah, someone was pointing out about the Chainlist RPC, they work most of the time. I don't know. If you definitely want a reliable one, like something like Alchemy or Infura is a better bet. Those public ones, they can be slow, they can be unreliable. That's why I kind of opt to use Alchemy. But so far, the ZKsync public one has been amazing and never a problem. So from here, we've created our contract, we saved it, we made sure it compiled, we've got everything set up for hard hat, and we can now actually write a script to deploy our contract. So we're going to create a file called deploy xNFT Sepolia, because we're going to be deploying to Sepolia. We're going to create it in a scripts folder because we don't have a scripts folder yet. So you can just do new file, type scripts / and then the name of the file. Or you could do a new file, create it, and then create the file within that directory, create a new directory, and then create the directory. So this script here, essentially what it's going to be doing is making sure you're on Sepolia, because, hey, we want to deploy to Sepolia first. It'll deploy out the NFT contract, tell you it's deploying it. It'll get your information from your account, so it'll let you know who the deployer address is. It'll check to make sure, hey, you've got some Ether in that address. It sets some stuff up for us already, like the CCIP router on Sepolia, the link token address, and the chain ID for Sepolia. You may be wondering, if I don't want to use Sepolia and I want to use something else, you can go to docs.chain.link, check out CCIP. My nice little menus on the side aren't there. Go to resources. Here you can see, link token contracts that we were talking about a moment ago. Also, you can look at the CCIP directory. So if you wanted to say start from Avalanche instead of Sepolia, here you get all the information there. One thing of note, not every network is connected to every other network. So here you can see Avalanche isn't connected to ZKsync currently, because the way that CCIP works is there's lanes set up between these networks, and not every network is connected to every other network yet. It's something we're always adding. So that's if you wanted to do something other than Sepolia. Cool. So we've got this script here. We set up our information. We then deploy our NFT with the information we needed for our constructor. And hey, we get back our deployed address. So we can go ahead and save this file, and we can run it with just hard hat run, the name of the script, and the network that we want to be on. We'll run that. Hold our breath, make sure it works, because live demos are the best. Wait for deployment. Double check here. I think all the questions have been answered. If you have a question that has been answered, feel free to drop it one more time, just so I can see it. Cool. So our NFT was deployed to this address right here. I would highly recommend, if you're following along, to copy down the addresses as we go, because you'll need them later. So I'm going to copy that down, just save it real quick. So we've deployed our contract on Sepolia. Fantastic. Now we're going to deploy it on ZKsync Sepolia. So basically, again, same thing, same set of steps, new file. This time it's ZKsync Sepolia. And we'll copy our code and paste it in. It's pretty much the same code. Looks about the same, right? We're doing the same stuff, deploying on a different network though. And the reason why we have a different script is because we have different router addresses, different link token, chain ID, all that stuff. We'll make sure that this is compiled for ZKsync. So we'll run npx hardhat compile with the network of ZKsync Sepolia testnet. That's the testnet that we were using. If you're curious, again, what, where, why this is happening, if we go look at our hardhat config, one thing is this ZKsync value within the network setup. It basically tells the plugin, hey, treat this like a regular EVM or treat this like ZKsync. And the compiler, as Antonio mentioned, does different stuff. So we want to make sure it's compiled for ZKsync, then that everything works there before we try to deploy it. Cool. So we successfully compiled all of our files, and now we'll deploy them. And it's deployed at this address, and it's going to be verified. I mean, right there, I think everybody can see ZKSync's a little bit faster than regular Ethereum, right? We had to wait a minute. I had to fill some dead air. And this time it's just boom, done, which is great. I don't know. I love it. I love the speed. So yeah, is it different? It's possible to create a different array of source chain selectors to interact with just one destination chain selector. So you're asking if you could have a bunch of different source chains all going to one destination chain? Yes, absolutely. You'd basically just do the same thing that we're doing, except for you'd kind of do it multiple times on different chains. Hopefully that answers your question. But yeah, you could absolutely set that up. Cool. So then we talked earlier about some of the best practices that we're doing, right? We're going to enable chains to talk to each other, and we're going to, enable the routers to talk to each other, and the source address that's going to be coming in and allowed to call. That's what we're doing here. So we're going to need the address of our NFT contract on both Ethereum and ZKsync Sepolia. We're going to need the ZKsync Sepolia chain selector. We're going to need the extra args gas limit that's encoded as bytes, which is this crazy value here. And we'll be passing all those in. So again, if you wanted to calculate the gas limit yourself, this is how you would do it. We've done it for you. So we can just use that value there. So we'll create another script called enablechain.ts. So we'll go to our scripts, new file, enablechain.ts. Paste this in here. You'll notice there's a couple values that we need to fill in. So go through here, it checks to make sure you're enabling from Sepolia for this one. And, oops, sorry, this should be called enable chain Sepolia. That'll make copying, pasting commands later much happier. So we, do the same basic thing where we check for, make sure that we have our private key, our RPC URL, we connect to the wallet, and then we're just basically calling a function on the XNFT contract on Sepolia called enable chain. So we're calling that function with these values. So we need to paste in our Sepolia address and our ZKsync address. So you can remember your addresses will be different than mine. If they're not different than mine, we've got big problems. But they should be different than mine. Okay, cool. So put those in there. And then from here, we can just call our script. And so again, this is calling that enable chain function. So we're saying to the Sepolia version of our contract, sorry, the Ethereum version of our contract, hey, you can do stuff on ZKsync. So that was successful. We can see the transaction hash. And then we need to do basically the same thing on ZKsync. We need to say to ZKsync, hey, ZKsync, Ethereum can do stuff with you. So we'll do the same thing again. We'll create a new script. And we'll copy this in. And again, we'll need to supply our two contract addresses. Oops, that one's the wrong one. That one's ZKsync. This one is Sepolia C7B1. Yes, we're good. Okay. And this is doing basically the exact same thing, just on ZKsync. So copy, paste. We've got that transaction. So now both contracts are allowed to talk to each other. On Ethereum Sepolia, we need to fund our NFT with 5 link tokens. So we need to take our Ethereum Sepolia address. You can use however you want. I'll just use MetaMask here real quick. We'll send to our Sepolia address. We'll send it some link. We can send it 5. And I understand that I'm sending it to a contract. We'll send it that link, confirm. We'll wait for this to go through. While we're waiting, I'm gonna go back to the very beginning, right? When I ran that transfer command and I was like, we'll get back to this in a minute, and we saw this here. That was for this NFT, right? So we'll see about adding NFTs in a minute, but I'm just letting you know that was for this NFT. So remember, the little knight dude is who we're talking about. Okay, so we've funded our contract, and now on Sepolia, we're gonna mint a new NFT. So again, we're gonna create a new script. There's a lot of scripts. To mint, so we'll copy and paste. And again, we need our Sepolia address here. So we'll let it know what contract we want to call the mint function from. So we've got that saved. We'll call our mint command. And we see this is going to take a moment here. If you want to see your NFTs, you can add them to your wallet. which is pretty cool. So NFTs here, if you click import NFT, you can give it the address. Well, that's not the address, that's a command. You can give it the address and then the token ID. So the first NFT that you mint will not be number 1. It will be number 0 because that's where computers start counting. So we'll see if this has been confirmed. It has. Cool. So we added our NFT. Remember, we had the knight already, the little ranger dude. That is who we just minted. Okay, so this is the live version and this is the pre-baked version. The difference is this is NFT number 1 instead of 0. So they go basically 0, 1, 2, 3. You get all 4 variants and then they start over. Cool. So we've minted this NFT. We've added it to our MetaMask if you are following along. So again, import, contract address, token ID, boom, you're good to go. We funded our contract. Everything's deployed. I think we're ready for the cross transfer from. So what this will do is this cross-chain transfer will take our NFT, burn it on Ethereum Sepolia, go through CCIP with all the information, and mint a new NFT on ZKsync Sepolia. So that's what will happen here. So that's what you can see. It's calling cross-chain transfer from, which in our XNFT, you can see here that cross-chain transfer from, right? This is the one that we looked at kind of at the beginning. We're creating that message that goes to CCIP. And you can see that we're burning our token ID first. So we're actually destroying the token and then sending the information across. So create a new script. Just copy and paste this name because typing is hard. New file. And oops. In here, we'll need to fill in a few things. So the address on Sepolia, and then the from and to, those should both just be your wallet address. So you can copy your wallet address, paste it in here and here, and then your token ID. So if you've minted 1 token to yourself, that would be token ID 0. In this case, we're paying in native. So we're paying with 1, which is link tokens. That's why we sent link tokens to our contract. And then we will call our script. Cool, and we get this transaction hash. Now this transaction hash, we can actually use on the CCIP Explorer. So if we copy that and we go to ccip.chain.link, this is the one that I kicked off at the very beginning. You can see it's done. So we'll check that out here in a moment. But if you went here and you pasted in your transaction hash and look for it, it may not be there yet because it takes a minute for this transaction to actually be confirmed. So we'll wait just a moment while this happens. But once this transaction is confirmed, it'll show up here, or it'll let us look at it here, and you'll see just like the transaction we looked at a moment ago, it'll look the same way except for, say waiting for finality. So cool. So with that, we've actually transferred across, right? So we can check out our transaction details. This is what we saw basically with the one I kicked off before, which you'll remember is the knight, right? So if we add them in, we can see them there. And now we'll check it out. So I'm on Sepolia right now. I've got my little knight. So I'll just take my contract address from ZKsync where I deployed this earlier, and we'll go check it out and see if he's over there. So we'll go to ZKsync Sepolia. And we'll import an NFT on ZKsync Sepolia. And remember, he was token ID 1 because he's the second one that I did. And we can see, hey, look at that. He's over there now. So if I went back to Sepolia and tried to actually look at this contract, we'll check this out, just kind of like proving my work here, right? So I'll take this contract address and I'll go to testnets.opensea.io to just take a look at this NFT. So you can see it's here, and you can see, hey, These guys, there's none of them, right? So he's gone from Sepolia. He's moved over to ZKsync Sepolia. I keep saying Sepolia instead of Ethereum Sepolia. I'm sorry. He's gone from Ethereum and he's now on ZKsync. So that's pretty cool. That's how you move between networks with your NFT. So I think at this point, Antonio has been kind of playing along. Maybe he baked a few things beforehand too. And he has something to show you about, like, so cool. We moved an NFT over to ZKsync. Like, woohoo. So what? Antonio's going to tell you why that's amazing. I'm going to stop sharing my screen. And yeah, I don't know, Antonio, if you want to share your screen.
I think to cover again this one. So I was running exactly the same thing that you did yesterday. I have my CCIP transaction from yesterday. You can see here I did it yesterday. So what I did is I created a typical Web3 application where you can connect your wallet with MetaMask in my case, and I'm actually going to switch to a wallet that doesn't have the NFT first, so I can connect with MetaMask, and this is like a faucet app that I created that, I mean, you can connect and you can mint some ERC test tokens that you want. As I don't have any of these NFTs in this app, I have to pay the transaction fee. And you say here, you don't own any NFTs, you'll have to pay the transaction fee. So if I click the button, typical MetaMask notification, I have to pay this fee. And if you see these balances, it will change in a minute. Yeah, it changed. And now I have more tokens. So that's the typical Web3 experience that we are familiar with. The cool thing with native account abstraction on ZKsync is that you can implement paymasters, which are these contracts that can pay the fees on behalf of the users. And you can do this on Ethereum with EIP 4337. But the bad thing about EIP 4337 is that you need a smart contract account to benefit from paymasters. And now we are using an EOA, we are using MetaMask. So in theory, I should not be able to use a paymaster to get free transactions. As I mentioned at the beginning of the talk, we have account abstraction implemented natively on ZKsync. And on ZKsync, even externally owned accounts are smart accounts. So that means that we can use paymasters. So what I did is I transfer one of these NFTs to this other account. So if I connect this one, it says, hey, you own one NFT, this transaction is free. So now I have a lot of ETH here, and I already have 1,000 tokens. But if I try to get more tokens, you see the message is different. That's because I'm not sending a regular transaction. I'm sending a paymaster transaction on ZKsync, which is an EIP 712 transaction. And you can see that this transaction has a lot of data, but it has a paymaster address, and it has some data that we are passing to the paymaster, this paymaster input. Once I confirm this, I get more tokens, but the balance doesn't change. So this transaction was totally free. If I see this transaction on the ZKsync Explorer, let me make this slightly bigger. You can see that this transaction actually, it was not free for the protocol itself. It's just that the user didn't pay for it. It was paid by this paymaster. And you can see here the details with the paymaster address, which is this one. It's an ERC721 gated paymaster that we called, because if you own one of these ERC721, one of these NFTs, the paymaster will pay the gas fees for you. This is a very basic demo that I built, but this is something that is happening on ZKsync on mainnet. We have a lot of teams building NFT collections, and then we have other teams building DeFi applications, things like that. And they are collaborating between each other, and you can see that you can go to a DEX, and if you hold one of these CK badges or one of these cool NFTs that we have on ZKsync. The transactions are free because they partner together. So this is a very cool thing that you can build and that is happening on mainnet. Another thing that I wanted to show you is the SSO demo that I talked before. The link is nft.zksync.dev, and this is this new library that we have built on ZKsync to make the user experience totally different from what we are used to. So as you can see here, this is a private browser window. There is no MetaMask, there is no wallet, there are no extensions here. So this is like, I'm a normal user, I have no idea what is crypto or what is a wallet. I can start using this app, I can sign up. It will tell me that it will create an account for me. I can accept, and then I will scan my fingerprint. And my fingerprint is the private key, and that's all I need to know. What has happened here is that the application has created a smart contract account for me. I don't have to worry about a private key or anything. I don't have to worry about having MetaMask or anything installed in my browser. I just have my finger. And now what I can do is I can mint an NFT. Minting NFTs is a great example, so we keep using it. So I can mint an NFT, and you would expect that I will need to accept a transaction or do something, but nothing happened. There was nothing required. I didn't need to put my finger or accept again. Everything was transparent, and this is a real transaction that you can see here in the Explorer as well. And this is because with ZKsync SSO, we have this thing called sessions, which, basically you can send many transactions and you don't have to accept each one of them. And sessions can be configured, can be like, okay, I want to enable a session just to interact with this contract or just to send this limit amount of ETH. So it opens the door to a lot of things that the developers can build and transform the user experience, because no need to install wallets, no need to accept transactions, no need to know how to store a private key or anything. It's a game changer, and this year will definitely be the year when we see applications that are totally different and that, my parents and my grandma can use.
Yeah, I think that's huge for sure. Like the Web3ification of Web3, right? Like making it feel just normal and comfy. I do always love, like, the term gasless transactions is so like misleading if you don't know what they are, because somebody's like, well, like how can it be gasless? But it's not. It's just somebody else is paying the gas for you.
Yeah.
Which there's a couple questions, and like somebody had asked, who are the paymasters and why would they pay for this transaction? And how you set it up, it's just you're the paymaster, right? Like you funded that transaction.
Yeah, it's normally the application developer. So if I'm Uniswap and I'm making a ton of money out of fees, and maybe I can create a paymaster, and if transactions are a cent or something like that, and I'm making more money on the exchange rate or whatever, I can pay the gas fee for the user, and it will be a way better experience, if the users, they don't have to see, okay, I have to pay 5 cents or whatever. It's time I want to swap some tokens. And it's normally the application developer that deploys a paymaster and takes care of that. Normally, it's the same way when you're building or you're using Facebook or Twitter or whatever. You are not paying for the infrastructure where they have deployed the application, etc. So, yeah,
that's a good point. Somebody was asking about, like, if a route doesn't exist. So I mentioned that you couldn't go from Avalanche Fuji to ZKsync Sepolia, and you're asking if you could go from chain A to chain B to chain C. So in this case, it'd be like Fuji to ETH Sepolia to ZK Sepolia, and you absolutely could do that. The only downside, in my opinion, is that, like, one, the amount of time it's going to take for all those finalities to be reached would probably, the more change you add, the longer that's going to be. And two, it's just going to cost more to do all that work. But you could do that. Like if you had to have a connection between chain A and chain C, when you're talking about that, then going through chain B, you absolutely could do that. Somebody else is asking about the risks when bridging an NFT. One thing that I definitely will say in this code, like this is not production code, right? This is example code. You'll notice that the NFT gets burned and then we call CCIP. If something were to be wrong with how you set up your CCIP call, that NFT is gone. Because that was step one, right? Like burn the NFT. So like that's a risk. And I don't think any of the standard risks with like smart contracts and if there's any sort of vulnerability in your code would apply as well. And yeah, last question I've got like queued up here. I'll check again if there's any more. Somebody's asked about using Ignition from Hardhat. I don't remember, Antonio, does the ZKsync plugin support Ignition yet?
Currently not, but we are working on it. And I don't know if you're aware, but there's a new version of Hardhat coming, V3, with some changes. So
okay,
that will be pretty cool.
Okay, cool. And then someone was asking about, in the example you did with the creating your wallet with the Touch ID, if you went to another piece of hardware, would that account be lost? And I think probably yes.
Not really, because the great thing about Apple and Google and all these companies that the passkey or the is saved in this secure enclave chip, and normally that if you have an iCloud account, that's backed up in the cloud. So the same account that I created right now on my laptop, I can use it on my iPhone. And the same thing if you don't have an iPhone or you don't have a MacBook and you're using an Android phone, it has its own version of this secure chip, and it's safe on the cloud as well. So you can recover the accounts that way.
Cool. Awesome. Last question I see
actually
is, oh, sorry. Go ahead.
Another thing is that we're going to build a recovery through email, which is thanks to ZK email, which is a protocol that you can create a proof that you receive an email, a typical email recovery that you get from Facebook or from Twitter or whatever with a code. You can, like in a few months, you can receive an email with a code, generate a proof, verify that proof on chain, and that's how it will work.
Cool. There's a question about extra args. In this example, it was just used for gas limits, but basically it allows future compatibility with CCIP upgrades and stuff like that. So if there's any changes that are coming with CCIP, having that extra args in there where you can pass in more data, it basically gives us that ability. Yeah, so I think from here, I'll just share my screen one more time. Clicking buttons. And yeah, if you want to learn more, if you want to do more, again, as Antonio mentioned, we have, the ZKsync docs, the smart sign-on that he demonstrated and talked about can be found at this link, as well as the NFT Paymaster. And then make sure that you're following ZKsync devs on X for any of the updates and latest information. I don't know if Tony, there's anything else you want to share?
Yeah, I just sent you a link through the private chat because someone was asking about having questions about Foundry, ZKsync, etc. So we have a developer forum. I don't know if we can share that link in the general chat, and we can maybe add it here as well.
There you go. I probably did the wrong capitalization on ZKsync. I'm sorry.
Happens to everyone.
And then from the Chainlink side of things, our docs are always there at docs.chain.link. We have a developer newsletter that you can sign up for, which is an awesome newsletter. And as always, our X, Twitter, it's Twitter account. Like I used to work at Facebook. I can't call it Meta. I'm sorry. And yeah, if you have any questions, like can I point to it? I can point to it right there on X. I'm at DRGDev. If you have any questions, feel free to tag me, DM me, whatever. And yeah, I think that's all we got. Unless anybody else has any like last moment dying questions. Antonio has anything sage wisdom he needs to share with everybody before we leave?
I don't know, eat your veggies, I guess.
I love it. Eat your veggies. All right, y'all. Well, thank you so much, everybody who stuck around and is watching this. Y'all are awesome. And yeah, with that, have a great one, y'all. Catch you in the next one.
See ya. Bye bye.